Hello, Matthews Gatos here. Welcome back to 11.1 Permutations Part 2. Let's get started. So I want to just review kind of what we've done before so we can kind of build on it with something like this. How many arrangements are there of? And we're going to look at 3 objects, 5 objects, and n objects. A little bit of a tip. When I'm talking about arranging objects, that implies no repeats. You can't duplicate objects that you're arranging. So looking at this, if I have 3 objects, there are 3 choices for my first position, and then 2 choices, decreasing by 1, and 1 choice. I stop when I reach 1 because there's no more objects to arrange. Let's look at 5 objects. 5 choices for my first one. I start at 5. Then I decrease by 1, and I get 4, and then 3, and then 2, and then 1, I stop. Let's look at n objects following these patterns. So see 3 objects, I start at 3. 5 objects, I start at 5. So n objects, I'm going to start at n. Notice here we decrease by 1, decrease by 1, decrease by 1. We stop when we reach 1. So if I start with n and I decrease by 1, I get n minus 1. If I take that and I decrease by 1, n minus 1 is n minus 2. If I decrease that by 1, I just keep going. So I'm going to put dot, dot, dot. I keep going and I stop when I reach 1. Well, this idea of starting at a number and decreasing by 1 each time and stopping when you reach 1 is called a factorial. So factorial is used when we're arranging all of our objects, and it's n exclamation point. That's red, n factorial. Now, n has to be a whole number because you can't take a negative factorial. So 0 factorial would be 1. 1 factorial would be 1 because there's only one possible arrangement. N factorial is n minus 1, n minus 2, all the way down until you get to 1. So my tip is start with n, whatever the number is, and multiply decreasing by 1 each time until you reach 1. 1 means stop. Now let's talk about how do we access this exclamation point, this factorial. On your calculator, you can go math, over to probability, and option number 4 is the factorial. If you have the CE calculator, it's just alpha window 9. So let's look at some examples using factorials. Let's say we want to evaluate this 8 factorial over 5 factorial without using our calculator. My tip for you is you start by expanding the bigger factorial and you stop when the factorials match. So I have 8 factorial and 5 factorial. 8 factorial is bigger, so I'm going to expand that. So I'm going to start with 8, and then I'm going to go 1 less, and multiply it by 1 less, and multiply it by 1 less. Ah, I see that these match. So I'm going to end my factorial there, and these cancel out. So 8, 7, 6, 5 factorial, which would really mean 5, 4, 3, 2, 1. Those cancel, and I'm left with 8 times 7 times 6, which is 336. Now remember, when it comes to factorials, the only way you can cancel a factorial is with another factorial. So now that we've seen this with numbers, let's look at it with variables. So here, I want to simplify n plus 1 factorial over n minus 1 factorial. So again, I identify the bigger one, which is n plus 1, and that's what I start expanding. So I'm going to start with n plus 1. So 1 less than n plus 1 is n. So I'm going to multiply it by n. 1 less than n is n minus 1. Ah, they now match. So I'm going to stop my factorial there and cancel. And what I'm left with is n times n plus 1. So my tip is you can leave it in factored form, n plus 1, or you can write n squared plus 1 plus n. That's okay as well. But I would just leave it in factored form. There's no real value into distributing it in, but just so you know, that answer is also okay. Here's how you can check it on the calculator. If you want to check the last question that we did, here's what we started with. Here's the answer that we end with, and you can check in the table, y1 equals y2 for all values, so I know that it is correct and I've done my question correctly. So let's try this one. N factorial over n plus 2 factorial. Well, this time the bigger factorial is in the denominator. So let's look at how we expand that. So I'm going to leave the n factorial and I'm going to start with n plus 2. So I'm going to go one less than that, n plus 1. They don't match. So I go one less than that, which is n. Now they match. So I stop my factorial there and they cancel. Remember, when they cancel, it's 1 because n factorial divided by n factorial is 1. So I'm left with 1 over n plus 2 times n plus 1. You can leave it like that, or if you want to do it, you can expand it out. That's okay too. Either one of those answers would be correct. So let's take this idea of factorials and take it one step further to solve an equation. So let's say we had n factorial over n minus 2 factorial equals 20. So I'm going to start the same process. I am going to expand my bigger factorial first because we need to get rid of the factorials before we can solve. So I have my n and I leave my n minus 2 factorial there. So I start with n and I go one less, n minus 1. And then I go one less, n minus 2. Ah, they match now, so I stop my factorial there, and that equals to 20. So let's look at what we have. We really have n times n minus 1 equals to 20. So this time we have to apply the distributive property because we're solving. So let's look. We have n times n, which is n squared, n times negative 1, which is negative n equals 20. Now I have a quadratic. I want to set that equal to 0 by subtracting 20. Okay, so now I have a nice quadratic, so I want to factor that to solve. So n squared minus n minus 20 factors as n minus 5 times n plus 4. I set each factor equal to 0. So for this one here, I add 5 to both sides to get n equals to 5. Here I subtract 4 from both sides and I get n equals negative 4. So while there are two solutions to the quadratic, there's only one solution to this question. Because remember I said to you that factorials have to be whole numbers. So I know you can't take a negative factorial, so n can't be negative 4, it can only be 5. Now the nice thing is, if you don't catch it here, you'll catch it when you check in your calculator. So here's my check. My original left side in y1, my original right side in y2. I start in my table and I look when x is equal to 5, y1 equals y2, so I know that they are correct. Okay, so factorials are going to bring us to how to solve permutations with repetitions. So I'd just like to introduce this to you now. Let's say I have three objects, A, B, C. I want to know how many arrangements I have. Well, for object number 1, I have three choices, A, B, or C. For object number 2, I have two choices. 3, take away the first object, 2 choices, and then 1 choice. 3 times 2 times 1 is 6. Or I could have said that was 3 factorial. So list out all the arrangements. There are all 6 arrangements of 3 objects, A, B, or C. Now let's apply some doubling up here. Let's do some repetition. Let's say we take those 6 arrangements and we replace every B with another A. So I'm going to replace this B with an A. That's going to become an A. That will become an A. That will become an A. And so will this and this. Do I still have 6 arrangements? Well, if you look at that, I have some that are the same. This one is the same as this. This is the same as this. This is the same as this. So I don't have 6 arrangements anymore. I now actually only have 3 arrangements. Well, why is that? Because I have to take out the doubles. I have to take out the ones that are repeated. So what I'm really going to do is I am going to take 6, my 6 ways, and divide it by 2 factorial. 2 factorial because that's the ways of arranging the identical A's. A and A, or A and A, flipping it around. There are 2 factorial ways of arranging 2 A's. So let's take this idea and look at how we solve permutations with repetitions. So if there are n objects in total, A of them are the same, B of them are the same, maybe C of them are the same. The total number of permutations is n factorial divided by A factorial times B factorial times C factorial. Now this is only used when all the objects are arranged. So what we're really doing is anytime there's repetition, always divide by the ways of arranging the repeats. Now the question won't tell you that there's repeats, so you need to look for repeats every question that you do. Let's look at this. How many arrangements of the letters in the word red deer begin with exactly one R? So the first thing that I look at is the number of letters. There are 7 letters and I see some repeats. There are 2 R's, 3 E's, and 2 D's. So I can't forget about those repeats. So what I'm going to do is arrange them and then divide by the repetition. So it has to begin with exactly one R. So this has to be an R. The next one can't be an R, and then I just have 5 letters left to arrange. So looking at red deer, there are 2 R's. So 2 choices for my first one. This can be anything except for an R. So 7 letters, 5 of them are not R. Take the R's out. And then I just have 5 letters to arrange. So that's 5, 4, 3, 2, 1. Multiply all of those together. 2 times 5 times 5, 4, 3, 2, 1. That's the factorial. But don't forget to divide by the repetition. R, there are 2 R's, so 2 factorial ways of arranging the R's, 3 factorial ways of arranging the 3 E's, and 2 factorial ways of arranging the 2 D's. Put that into your calculator and you can see there are 50 ways of arranging the letters in the word red deer that begin with exactly one R. Let's look at another one. So Teo lives 3 blocks south and 5 blocks east of an ice cream store. How many different ways can he walk the 8 blocks home from the ice cream store? So for me, I'm a visual person. The first thing I want to do is have a picture. So there's my picture. There's the ice cream store, and 3 blocks south and 5 blocks east, there's Teo's home. So I want to know, what are all the different pathways he could go from home to the come home from the ice cream store? So just to start us out, I just want to draw one possible route. There are several. There's one possible route. Now let's describe that route. If you were going to tell someone the route that you went, see, I went east, south, south, east, 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 south, east. So if I wanted to describe the route, that would be how I would describe it. But as I said, that is only one possibility. So this is kind of like a repetition question. I can find all the pathways if I treat it like arranging an identical object. So see how there are 8 letters? There are 8 letters that we want to arrange. 3 of them are S's for south, and 5 of them are E's for east. So I can put that all together like this. 8 factorial ways of arranging all those 8 letters. Divide out the repetition. 3 factorial ways of arranging the identical S's. 5 factorial ways of arranging the identical E's. Put that in our calculator and we can see there are 56 ways for him to go from the ice cream store home. So putting permutations all together. We've already said that they're arrangements, but they are ordered arrangements. Now you can have all of the set or part of the set. I'm going to show you another way other than the fundamental counting principle as to how you could do a permutation, and that is NPR. NPR means I have N objects and I'm taking them R at a time. Now the formula, which is on your formula sheet, NPR, is N factorial, the ways of arranging all N objects, divided by N minus R factorial. Well, that's the way of arranging the objects I don't pick. So this is the formula that you have. There's also a button on your calculator. So just like where you found the factorial, we can go math probability. Option number 2 is our NPR button. If you have a CE calculator, it's alpha window 7. Now, any question you can use fundamental counting principle for, you can use NPR. We're going to get into a question where we're going to do it with fundamental counting principle and with permutations, but I just want to highlight with you a couple of common permutations that you won't necessarily have to plug into your calculator. So for example, if you have NPN, you have N objects and you're arranging all N of them, well, that's just what we just talked about. That's a factorial, N factorial. So for example, 5P5 is the same as 5 factorial. Now, NP1, if you have n objects and you're taking one of them at a time, there are always going to be n ways of that happening. So 5P1, for example, just 5. So you don't need to plug that into your calculator if the second digit is a 1. NP0, that's the number of ways of taking 0 objects or arranging 0 objects from n. That will always be 1. For example, 5P0 will be 1. So those are some ones you can kind of keep to memory so you don't have to punch it into your calculator. So let's look at an example where we're comparing permutations to fundamental counting principle. I want to know how many different arrangements of the letters in the word tables can be made using at least 4 letters. So first of all, at least is a minimum. So that means a minimum of 4. So that could be 4 or 5 or 6 letters. So at least really needs cases. Now, tables, there are 6 letters. There are no repeats. That's really important to note. So the first way we're going to do this is with fundamental counting principle. So here's my cases. 4 letters, 5 letters, or 6 letters. Those are all my cases. So if I want to arrange 4 of the 6 letters, so I have 6 choices, and then 5, and then 4, and then 3. If I want to arrange 5 of the letters, that's just 6, 5, 4, 3, 2. If I want to arrange all 6 of the letters, that's 6, 5, 4, 3, 2, 1. Now remember, these are cases and or means add. So if I put that into my calculator, I would do each of these cases added together and get that there are 1,800 arrangements of the letters in the word tables using at least 4 letters. That's one way of solving it. Now that we know the answer, let's look at the NPR way of solving it and see if we get the same answer. So here, how many different arrangements of the letters in the word tables can be made using at least 4 letters? So again, I'm going to look at my permutations. So I can have 4 of the 6 letters, 5 of the 6 letters, or 6 of the 6 letters. So I still have cases. So in this first one here, I have 6 letters and I'm taking 4 at a time, 6P4. This one here, I'm looking at 5 of the 6. So that will be 6P5. On the last one, 6 of 6 would be 6P6. So again, or means add. I can put that into my calculator, and or means add, and you see I get the same answer. So you can use fundamental counting principle or the NPR button on your calculator, whichever you prefer. So I just want to end with this example here where we're solving for n. In this equation here, NP2 equals to 56. Well, using our formula, NPR, this is our formula, let's substitute what NP2 would look like. So NP2 would be n factorial over n minus 2 factorial. Well, we've done a bunch of questions like this before, so let's just go ahead and look at that. So n factorial over n minus 2 factorial, that's NP2, that has to equal to 56. So first things first, I want to expand my bigger factorial, and n is bigger. So I'm going to expand that. So I'm going to start with n, and I'm going to break it down till it matches n minus 2 factorial. So I start with n and I go 1 less, n minus 1. It doesn't match, so I go 1 less. Ah, it matches now. So I'm going to stop my factorial there and I cancel. So what I'm left with is n times n minus 1 equals 56. So let's apply the distributive property. So n times n is n squared. N times negative 1 is negative n, and that will equal to 56. So with quadratics, we always want to set them equal to 0. So we have n squared minus n minus 56 equals 0. So now I have to just factor that. So two numbers that multiply to negative 56 and add to negative 1. Go ahead and factor it, and then I set each factor equal to 0. N minus 8 can equal 0, or n plus 7 can equal 0. So here I just add 8 to both sides to get n equal 8. Here I subtract 7 from both sides to get n equal to negative 7. So remember, because I'm solving for n is the total number of objects, I can't have negative. So that is an extraneous root. So the only solution would be 8. Now I can check that on my calculator as well. So on my calculator, I'm going to put left side in y1, right side in y2, and look in the table when n is equal to 8. So remember, the check always happens in the table. Now, if this was a numeric response question, you wouldn't have to go through all those steps. You could just use the calculator to help you. So let's summarize our lesson. N factorial is the way of arranging all n objects. When we're simplifying factorials, expand the larger, stop when you match the smaller. When you're arranging objects with repeated elements, always divide by the ways of arranging the repeats. And anything you can use fundamental counting principle for, you can use your NPR button or formula to do that. So in this pie eating contest, this guy says, I will eat 6! Exclamation point. And this math guy says, there's no way you can eat 720 pies. Get it? 6 factorial is 720. Brilliant. You guys can move on to the practice questions in my notes. Detailed solutions are on D2L, and then move on to the textbook questions. I hope this video helped, and I look forward to seeing you for the next one.